Right. Hi, dear friends. I'm going to explain about how to draw the shear force and bending moment diagram for a cantilever which is carrying a point load capital W at the free end. Now, for this purpose, I have drawn a cantilever beam here. This cantilever beam, capital AB, it has got a length L and it is carrying a point load capital W at the free end, capital A. Now, the first thing what we need to do here is I'm just considering a section capital X and X. Now, this section is located exactly at a distance of x from the free end capital A. Now I'm considering either right or left side of the section. As there are no forces which are acting on the left side of the section, I'll be going with the right side of the section. As you can see, there is only one force which is acting on the right side of the section now, and there are no other forces which are acting on the beam. Now here the shear force exactly at point A will be equal to capital W, that is positive W, and shear force at capital B will again be equal to capital W, that is positive again, because according to sign convention which I gave you in the previous class, towards right side of the section when a force is acting in the downward direction it has to be taken as positive, and towards left side of the section when the force is acting in the upward direction it has to be taken as positive. Similarly, if I consider a sectional line here, this one should be taken as positive. Same thing again, right side downward and left side upward should be taken as positive. Now again, when we consider right side upwards and left side downward, it has to be taken as negative for shear force. So please keep this thing in mind, this sign convention. Now coming back to the same thing again, the shear force which is acting at point A will be equal to plus W, and shear force at point B will also be equal to plus W. Shear force at point A will be equal to plus W and shear force at point B will be equal to plus W, as there are no other forces which are acting on the section. Now how to draw the shear force and bending moment diagram here. Now let us go with the shear force diagram. It is nothing but a graphical representation of how the shear force and bending moment are varying. Now first thing what we need to do here is we have to draw a baseline. Now I am drawing a baseline here. Now this baseline is capital AB, and whatever the measurements which we consider, right, above the baseline it should be positive and below the baseline it has to be negative. Now the values which I obtained here, right, the shear force at point A will be equal to plus W. So I am indicating plus W in the upward direction. So this is plus W, and exactly at point B again it is equal to plus W. Now so this exactly is the shear force diagram which we need to draw with a positive sign in the middle, which is simply indicating the positive shear force. Now it's turn to develop the bending moment diagram. For this thing, what I'm going to do here is just I'm considering the same section. Towards the right side of the section there is only one force. Now bending moment at any section, capital X and X, it will be equal to W multiplied by X, W multiplied by X, force multiplied by perpendicular distance. But according to sign convention which I gave you, any moment which is making the beam to bend in the downward direction or to get convexity, that has to be taken as negative bending moment. Now here this force is trying to bend the beam in the downward direction. With respect to this particular section, we have to take that one as negative. So it will be equal to minus W multiplied by X. Minus W multiplied by X is the moment, bending moment. Now let us go with the sections. Now I want to calculate bending moment at section X is equal to 0. Bending moment at any section X is equal to 0. So bending moment at section X is equal to 0, that means it is exactly at point A. Now bending moment at point A, that will be equal to minus W multiplied by 0. This is equal to 0. Minus W into 0, it is equal to 0. Same thing again, bending moment at X is equal to L. Bending moment at X is equal to L. That means from point A up to point B, right, it is equal to L. So we are calculating bending moment at point B. bending moment at point B will be equal to minus W multiplied by L. So this is minus W into L. Now how to plot the same thing on the bending moment diagram? So exactly at point A, we have bending moment which is equal to 0, and exactly at point B it is equal to minus W multiplied by L. As I told you earlier, with respect to the baseline, all the negative values should be plotted below the baseline, positive values should be plotted above the baseline. Now exactly at point A, bending moment it is equal to 0, and exactly at point B the bending moment is given as minus WL. Minus WL should be plotted below. And now between A to B, how does it vary? Will it be linear? Will it be parabolic? No, it will be linear. Parabolic will get parabolic curve when it is a square. Whatever the equation which you are seeing here, when it is a square, then we'll be getting a parabolic curve over here. As it has got only 1 degree equation, right, minus W multiplied by L, it will be linearly varying, uniformly varying like this. Now this has to be negative. Now this one is the shear force diagram, and this one is the bending moment diagram. Suppose I want to get the bending moment exactly at a distance of L by 2. Suppose I am marking L by 2 here. I want to know the bending moment exactly distance of L by 2. Now here I am going to substitute bending moment at a distance x is equal to L by 2. So this will be equal to minus W multiplied by L by 2, that is minus W L divided by 2. Now exactly at distance of L by 2, this particular thing here, it is equal to minus WL by 2. That is equal to minus WL by 2. So just these are the shear force and bending moment diagrams for a cantilever beam which is carrying a load capital W at the free end. So thank you friends, that's it for today.